Good morning, everybody. I'm Tim Rogers, and as you might be able to tell from my accent, I'm from London in the rainy United Kingdom, although actually at the moment the weather at home is better than here, surprisingly. We're going through a heat wave in London. It's sort of 30 degrees or so. I'm a software engineer at a fintech startup called GoCardless. To give you some context before I start talking to you about how to build APIs, I'd like to tell you a little bit more about what GoCardless is and what we do, so that you can see where my expertise comes from. So at GoCardless, we're building a bank-to-bank payments network for the internet. So what does that mean? Well, we're all familiar with the credit and debit card networks, things like Visa, MasterCard, and American Express. Alongside these credit card systems, which have lots of intermediaries, lots of middlemen, there's also an alternative, bank-to-bank payment networks. Unlike the credit card system, these networks involve just putting money from one bank account and dropping it in another. There's not kind of 3 or 4 people in the middle, each of whom wants to take a cut. Most of these systems are country-specific. For example, the direct debit system in the UK, or Bank Giro in Sweden, although in the Eurozone there's actually a system that works across all of the Euro countries called SEPA direct debit. There's 2 reasons why businesses use these payment methods. The first one is that they have less churn. Credit cards expire, which means that your customers accidentally drop off even if they don't actually want to cancel. That means as a business you lose revenue because your customers just disappear and don't come back. Secondly, these bank-to-bank payment networks are much cheaper than using credit and debit cards, which means that you make more money because you don't have as high costs. The aim of GoCardless is to build a really simple API that bridges these national payment networks together so that you can do one integration and collect payments anywhere. APIs are at the very heart of our business, as we want to allow you to access these networks with a simple, beautiful API. Building APIs, I think, brings some particular software engineering challenges, especially when users are relying on your API to run their business. At GoCardless, therefore, we've built up a bunch of experience around designing and implementing great APIs. And today I'm going to talk to you about building APIs with Rails. It's not as simple as just turning on API mode in our Rails application. There's a lot more to it. In this talk, I'm not going to let you in on some kind of incredible secret or a weird trick, but rather I'm going to talk about how you can apply basic software engineering principles in order to build better APIs and make your code more maintainable. In particular, I'm going to talk about a pattern called the middleware pattern, which is based on these software engineering principles and helps you to write better, more maintainable code. So when I say maintainable, what is it that I mean? I'm talking about 4 things there, really. I'm talking about understandability, testability, reusability, and adaptability. Let's go through those in turn. Firstly, we want our code to be understandable. We want code that we or another member of our team can come back to in a day or a week or a month or a year and actually understand what's going on. We want our code to be testable. It should be written in such a way that it's easy to test, so we can be confident that it works now and confident to make changes in the future. We want our code to be reusable, so we can provide a consistent interface across our API. For example, having our authentication work the same everywhere. When we want to make changes to our API, we don't want to be forced to change our code in hundreds of places. We want to have a single point where we need to make a particular change. And finally, we want our code to be adaptable. It should be able to evolve over time, rather than being resistant to change. In this talk, I'm going to focus on understandability, testability, and reusability. Let's get started by building a simple API using ActionController. That will help us to understand the maintainability challenges that we face, and then we can think about how we can refactor our code to make it more maintainable. So let's start off by imagining a really simple API. It creates a customer based on their email address and bank details. So we'd start off probably by making a customer's controller, which inherits from ApplicationController. We'd then add a create method, our first controller action. We'd build a customer from the incoming parameters from the request, and then we'd try to save it. If it saves properly, then we render back the customer as JSON. If something goes wrong, then we render back the errors to the user. This is all very simple so far, right? But we're missing a lot of important things here. So for example, as I've already mentioned, our API would need some kind of authentication. The most common way of doing that in an API is to use the authorization header, sending an access token in there. So we could write the code to handle this authorization header straight into the create method, but that immediately makes our code a lot less maintainable. Our code is immediately harder to understand. Straight away we have a long method doing lots of jobs, with no division of labor. Our code's also harder to reuse. The authentication part isn't abstracted out or separated away, but rather it ends up living in the create method. And thirdly, our code is hard to test. You can't exercise the authentication logic on its own, but rather only in the context of the controller. That means that you're forced to use integration tests rather than being able to simply unit test in a faster way. The most common solution to this problem in the world of Rails is to split out the authentication code into separate methods, using Rails' filter functionality. So here, we define a method called checkAuthorizationHeader, and then we tell Rails to run it before our controller action with beforeAction. Filters let you run code before, after, or around your controller action. So we define our filter, and then it will be run before the controller action. In our checkAuthorizationHeader method, we look at the headers, pulling out the authorization header. If the header's missing, then we return an error. It's important to note with filters that if we raise an exception or return an HTTP response, as we do here, execution will stop. Otherwise, Rails will move on to the next filter in the chain and eventually onto the action itself, so our create method from before. Once we've checked whether the header is actually provided, then we can look at its value. If we look back, the format of this header is that it should have bearer, then a space, then an access token. So we split the header into its parts, and then we check that it starts with bearer, returning an error if it doesn't. If everything looks good, we save the access token to an instance variable, @accessToken. Now, having extracted that access token, we want to actually check whether it's valid, whether there's a user that it matches to. So we add another filter, checkAccessToken. In there, we look up the access token which we've already saved to our instance variable and store the authenticating user in a new instance variable, @user. If there's no match, then we return an error. Otherwise, we've reached the end of our filters and Rails will move on to the controller action. Now in the controller action, we can make use of our instance variables from before. So for example here, we merge in the user to the parameters so we can make our customer belong to the user who's authenticating. There are tons of other things like this that we might want to do in filters. For example, validating input against an API schema, recording statistics about who's using the API, or enforcing users' permissions. We'll look at just one more real-world example from GoCardless. Let's say that we also want to translate the API's error messages into the user's language. There's a standard header in HTTP that you can use to specify the language you want your response to be in. So for example, as a random example, let's say that we want the errors to be in Ukrainian. In that case, we'd set this accept language header to UK-UA. And then we'll add another filter to our controller to handle this time using around action, which lets us, as the name suggests, run some code around our controller action. And in there, we'll use Rails' built-in internationalization functionality to use the language that was specified in the request. And with that setting configured, we can continue on to the rest of the filters and to the action using yield. Very quickly, this approach of adding more and more filters gets really out of control, leading to a world of pain and unmaintainability. Here's a real-world example from a controller at GoCardless until we refactored it. It used to power our overflow, and in the worst case, it had no less than 12 filters before the actions got run. This gets really confusing to use, and it gets really painful. So what's happened here? Why does our code get out of control so quickly? Where do all these filters in our API come from? So the create method in our controller contains what I call the endpoint-specific logic, the code which you don't need to reuse. It does a one-off job. Here, it creates a customer based on the incoming request. This code tends to stay relatively simple, and if it gets more complex, then there are well-known solutions in software engineering to deal with that. So we might, for example, move the code to create the customer to a service object, another class that we can test independently. What we've been doing here, though, is adding reusable code, which we'd use across our API, things like authentication and internationalization. You get a lot of this kind of stuff in APIs because they're designed to provide a rigid and consistent interface to users, which means that you're likely to have a lot of shared and reusable logic which provides that interface. So what's the problem here? Even by adding just a few of these filters, we've already hit 3 problems that make our application much less maintainable. Firstly, our code is hard to understand, particularly in the way that it uses state. We naturally want to split our logic into different methods to make our code as clear as possible. For example, we split parsing the header from actually checking whether the access token exists. But splitting those parts up into steps means that we then need to share data between the different steps and make data available from the filters to the controller action. For example, in this case, we wanted to be able to use the user in the controller action. We end up using instance variables, which aren't easy to reason about. The flow of data isn't at all clear, and you end up, when you're writing code, scrolling up and down your file endlessly, working out where a particular instance variable came from and how it got there. This doesn't make a good developer experience. Secondly, our code's really hard to reuse. The filters just live in the controller. It's difficult to share them, reuse them, or adapt them. We'll end up just duplicating this code when we want to add another API. For example, an API to collect a payment from a customer. And thirdly, our code's hard to test. We want to be able to test the edge cases in our logic. For example, what happens if the authorization header is missing? What happens if a language that we don't support is specified? We want to be able to test the state that is constructed. So, for example, what data we store and fetch in instance variables for later, as well as any response sent to the user. The solid principles are a series of software engineering design principles which can help us to make our code more maintainable. One of these principles is called the single responsibility principle, and this is at the heart of the middleware pattern that I'm going to talk to you a bit more about today. The single responsibility principle helps us to make our code more understandable, more testable, and more reusable. So what is it? The single responsibility principle says that every module or class should have responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class. In other words, in an ideal world, we want to turn each of these filters into a single class with a single responsibility. This makes our code much easier to test, understand, and reuse. So before we dive into this middleware pattern, let's have a look at what the Rails solution is to this problem so we can see whether that works for us. So far, we've been using filters defined within our controller. Now, this is certainly better than adding the logic to each controller action, but there are still maintainability challenges. The Rails documentation offers us a few options, which I'll go through now. Firstly, we can move our filters from customer's controller, so the concrete controller, to application controller, our abstract controller. So here we take the methods and we move them to application controller. Then we have 2 options for actually using those filters that are defined in application controller. If we're really sure that we want a filter to run for every action, then we can call before action in application controller. And if we want a bit more control, then we can call the filters within the customer's controller. So there we've looked at how we can share the methods. A second option is to move the filters into their own modules, and then include those modules into our controller. This is the standard Ruby way to share code between classes. So here we create a module, API Authorization Header, and then we define our check authorization header method in there. That's the code that we want to share. We can then include that module into our controller, and it will behave just like it's a method that's defined in the controller itself. So we can just use before action. Alternatively, if we want to be extra clever, we can use a little-known Rails feature called active support concern, which lets you automatically add the filter when you include the module. So we'd include the module in our controller as usual, and then in the module we would extend it with active support concern, and then add this special included block. This included block is run as soon as the module is included somewhere else. So here we can make sure that the before filter gets set up automatically. So now we've been able to separate the logic into its own class, but it's still not easy to test. So what other solutions are there? The final option that Rails offers is what's called a filter module. This gets us a little bit closer, with the logic separated out and a more easily testable interface. We start by defining a module, so again, we'll call it API Authorization Header. And then on that, we define a before method, which gets passed a controller. We could do the same thing for an after or around filter, using the obvious corresponding method name. This means that we can do everything that we could do with our previous patterns. We can see the request, so we can inspect the headers. We can send a response using the controller's render method. And we can even store state on the controller, so for example, storing the access token to use later. We use this filter class by passing its name to before action. So now our filter is abstracted out and fairly simple to test, since we can pass it a fake controller and see what happens. So for example, what is returned and what state is stored. But using instance variables for state still leaves things quite confusing, and it isn't that easy to test. It feels quite janky and doesn't feel like a great developer experience. So it feels like the Rails way doesn't really give us what we want. It doesn't get us to where we want to be. We haven't been able to find a good solution. So let's see how the middleware pattern can help. Using the middleware pattern helps us to write easy to understand, easy to test, easy to reuse code. So what is it? Surprisingly, Microsoft's ASP.NET documentation actually has one of the best descriptions of how middleware work. Middleware is software that's assembled into an application pipeline to handle requests and responses. That is to say, we chain together a bunch of individual middleware into a pipeline, and then those middleware work together to handle the request and build a response. Each middleware can do two key things. Firstly, it can choose whether to build a response itself or to hand on to the next middleware in the pipeline. So for example, a middleware could check whether an access token was missing from the header, and if it was, it could return an error to the user. Or if that access token is there, then it can delegate on to the next middleware in the chain, in the pipeline. And a middleware can perform work before or after the next middleware in the pipeline. So for example, a middleware could fetch some data and pass it on. Or it could even run the next middleware in the pipeline and then write something to the logs afterwards. You have a bunch of flexibility there. The middleware pattern has been particularly popularized by JavaScript frameworks like Express, as well as in a variety of other frameworks and languages, for example, Elixir's Phoenix. So what's so great about this pattern? Why is it that building our application as a series of middleware, these discrete classes, helps us to make our code more maintainable? At the heart of this is the single responsibility principle. Instead of big, unwieldy pieces of code doing many jobs, instead, we have many simple classes with a single job. Our code is easy to understand because each middleware does one simple thing. We then assemble a bunch of different middlewares together into a pipeline, and they can work together to produce a complex result. Our code is reusable because each middleware has one job, and then we can compose them together to build the more complex functionality. We can even make them configurable if we want for more reusability. And finally, our middleware are easy to test. You can call the middleware, passing in some input, and see what happens. So for example, you can see what response is returned, or if the next middleware in the chain is called. Now, hidden from view, middleware are actually behind how Rails works already. Rails is built on Rack, which is a Ruby framework for building modular web applications. Before the code you've written gets run, and even before Rails gets run, a bunch of middleware get things ready for your application. Here's an example. In Rails, there's a middleware included called Action Dispatch Request ID, which by default runs on every request in the development environment. You might have spotted in your logs this request ID being recorded, and if you look at the response from your Rails application development, you'll see an X request ID header, which contains a unique identifier for your request, which can help you trace it end to end. That's all powered by this middleware. On the screen, you can see a simplified version of it. It takes a look at the incoming request, represented by env. It then generates a request ID and stores it on the request state, so it can be used by later middleware in the pipeline, and even by your own application code. Then it calls the next middleware in the pipeline with this app.call. And then after that middleware has done its job, it then adds the request ID to the response headers. Rack middleware actually do roughly what we want. However, Rails doesn't make it easy for us to plug them in on a request-by-request basis. Instead, we have to configure them for our entire application. Whereas we really want to have more flexibility. We want to be able to compose flexible chains of middleware for different jobs. We don't want to be forced to use the same ones in every single request. So let's see how we can refactor our API using the middleware pattern. For this talk, I built a simple implementation of the middleware pattern in about 25 lines of code. I'm going to talk through it now, but you can also find it on GitHub at github.com/timrogers/simple_middleware. Don't worry, I'll give you another chance to get these URLs and stuff at the end. So let's go through that library together and then re-implement the API we've already built using it. First, let's look at the interface, how we actually start using our middleware from the controller. The create method in the customer's controller ends up looking like this. We call simple middleware with a list of middleware we want to run through and specify the state that we want to pass in, so the data we want to have accessible in those middleware. Here we say we want the request, so we can look at the headers, and we say that we want the parameters. It's worth noting here that I've also defined a final middleware called create. In there, we'll put the endpoint-specific logic that actually creates the customer. We could do this a bit differently and keep the endpoint-specific logic in the controller action rather than moving it to a middleware. I've chosen to write it as a middleware, though, for consistency, and so we can unit test that part on its own if we want to. At the end of the middleware chain, then we expect to get back a rack response, which we render back to the client. A rack response is just an array containing a status code, some response headers, and a response body. We'll have that same kind of response whether we got an error in an early middleware, or if the create middleware got right to the end and successfully created a customer and rendered it back. So we've seen what the interface is. That is how we use simple middleware. Now let's take a look at how it's built. The base middleware class itself is super simple. I've already talked about how a middleware can do two things. It can either return a response, or it can call the next middleware in the chain. A middleware gets initialized with the next middleware in the chain after it, which we make accessible with an attribute reader. It's then up to each middleware to define its call method. That method can use the state, and then it has two options. It either returns a response, or calls the next middleware in the chain, passing in the state, which it can add to along the way. Thinking back to our example, we put together a pipeline of 4 middlewares, one for handling the language, one for fetching the authorization header, one for looking up the access token, and then a final one for creating the customer. Each middleware performs a single job, and then they work together to handle the request. Our pipeline gets run through in the order that we specify. This is important as some of our middleware depend on other ones. For example, the access token middleware depends on the access token that was provided by the authorization header middleware. We also want our code that handles the locale to run first, so we have everything in the right language. And then at the end, we want to run the endpoint-specific logic. This is a bit like a Russian doll. They're all stacked together, and each one can only see the one next above it. Each middleware in the chain knows which middleware is next. It does its work, and then either returns a response or calls the next middleware. The code to actually put together our chain of middleware is really simple too. Here's that simple middleware.call method that we saw on the interface. It takes the list of the middleware passed in, and then stacks them into a pipeline, where each middleware knows about the next middleware in the pipeline. Once we've built the chain, we just call the call method on the first one, passing in our initial state, and then it cascades down. For the state, I'm using an immutable hash here, provided by the gem immutable Ruby. Immutable hashes can't be mutated. That means they can't be changed. All the operations that you perform on them, for example, adding a new key or changing a value, return a copy of the hash with the change you've just made. Using an immutable data structure is really great as it gives you more confidence in your code and helps you to avoid bugs in your pipeline. So let's go through what happens when we call our pipeline of middleware. Firstly, the locale middleware gets called. It sets the language and then calls the next middleware. Now we're in the authorization header middleware. It checks the header, and if it's missing, then it returns an error, in which case our pipeline stops. Otherwise, we'll call the next middleware in the chain, passing on the access token that we've just extracted. Then we land in the access token middleware. It looks up the access token, returns an error if there's no match, and if there is a match, it keeps the user and then delegates on to the endpoint-specific code, the create middleware, which is then responsible for creating the customer and rendering back. So that's a little look at how simple middleware works. Now we'll actually have a go at refactoring our API using it to see how simple it is to use. You'll find the full source on GitHub as well. You'll be able to download the code for this example at the end as well, but again, I'll put the links up at the end, so don't worry about taking it down. Let's think back to our initial controller from the beginning. We want to refactor these three filters with locale, check authorization header, and check access token into middleware using simple middleware. We then also want to rewrite the create method as a middleware too, to go at the end of the pipeline. Any specs we've already written for our controller can really help us out here. They can act as integration tests as we move our controller to the middleware pattern, testing the edge cases and giving us confidence as we make changes. I've already written some tests for the original controller, which you'll find in the GitHub project. We're going to skip doing the with locale filter since it isn't very interesting, and go straight to the check authorization header filter. Let's turn that into a middleware and then add some unit tests. The fundamentals of a middleware are simple. We have a class. Here we call it API Authorization Header, which we say inherits from simple middleware. It defines a call method, which expects to be passed the current state. The call method can then access the next middleware in the chain and call it, or it can return a response itself. Thinking back to the controller, in the initial state, we passed in two things, the request and the parameters. The request exposes the HTTP headers, so we can look in the state, find the request, and pull out that header. Now we check the header, and with exactly the same code as before, and we can return an error if the header doesn't exist. Simple middleware also defines a render method. It's just a simple helper that returns a rack response, which is an array with a status code, response headers, and body. In our controller, we take that response and render it back to the user. So what about the case when the access token's there and it looks valid, and we don't need to return an error? We want to take the access token that we've just found and pass it on to the next middleware in the chain. To do that, we generate a new state by calling the put method on our initial state, which returns a new copy with the access token added. We then call the next middleware in the chain with our new state. Now our state looks like this. We have the request and the params from before, but we've added an access token to that. So now we call the next middleware, passing on the new state. The next middleware in the chain is responsible for checking if the access token actually exists. The beauty of the middleware pattern is that we can write really simple unit tests, passing in the initial state and a fake next middleware, and then we can check what is returned or whether the next middleware gets called. Let's look at how we'd do that. So the setup for our test is quite simple. The subject is an instance of the middleware. When we instantiate a middleware, we pass in the next middleware in the pipeline. The next middleware is just an RSpec double. This is just an object which responds to call and does nothing. In our tests, we can check whether this next middleware gets called with an RSpec message expectation, which we'll see in a few seconds. Our initial state is just a fake Rails request with some headers. You might remember that in our controller we passed in the request and some parameters. But in this test we'll just go with the request since we don't need the params. We might as well keep to the bare minimum state required. So let's write our first example, the case where there's no authorization header. So we passed in a blank set of headers, and then we check what response is returned. So here we expect this rack response with a 401 status, headers to say that it's JSON, and a body that says that the access token is missing. The case where the header isn't structured correctly is very similar. This time we pass in a header that doesn't start with bearer, and then we check that we get a similar error back. The final case that we need to test is where the authorization header is present and valid. In that case, we want to make sure that the next middleware in the chain is called and is past the original state plus the access token that has been pulled from the header. We use an RSpec message expectation here to say that the next middleware should have received the call method and should have been passed the original state plus the access token. We don't expect anything to be returned. That's the job of the next middleware in the chain. We just check that the next middleware is actually called. Now let's go through the access token middleware. We'll go through this one a bit more quickly, since we've already seen an example. We pull out the access token from the state, which has been added by the authorization header middleware. We then look for a user with a matching access token. If there's a match, we call the next middleware, passing on the authenticated user. If there isn't a match, then we return an error. So we have two cases that we want to test here. The setup for our second middleware looks pretty much the same as the first one, except this time we only need an access token in the state. Our first test is for the sad path, the case where the access token doesn't exist. We want to check then that the right error message is returned, so here that we return an invalid access token error. The happy path is where the access token is valid. Here, we create an access token, and then we check that the next middleware is called with the user passed on. We're going to skip our middleware for setting the locale for now. So all we have left now to write is our endpoint-specific code, the create middleware. Here, we want to build a customer, try to save it, then either render back the created customer or return an error. We use the state to build the custom parameters. So what does that look like? In the state, we have the parameters, the request, and the authenticated user. We just care here about the parameters and the user. So we pull out the email and the IBAN from the request parameters, and then we merge in the user that has just authenticated from the state. Having built the customer, we try to save it, and then either render back the created customer, or if something goes wrong, then we render back the validation errors. If everything has gone to plan and we haven't made any mistakes, our controller specs will still pass. So now we've refactored our API using middleware, and I think we've made it significantly more maintainable with this single responsibility principle-based pattern. This is quite a big paradigm shift and a mental change from working with Rails and controllers, so it might take some time to get your head around, but I'd recommend having a play with it, because using this can also just change the way that you think about things and think about your application. Even if you end up sticking with using controllers, it might make you see things in a different way and help you to write better code anyway. So you can find this example on my GitHub at github.com/timrogers/simple middleware example. So we've learned how to make our API more maintainable with middleware, but I wouldn't actually use this simple middleware library. With a more fully featured middleware library, we can make our APIs more maintainable and do it in a way that has a much better developer experience. I've just built this really simple implementation for this talk because it helps us to understand the core principles without getting confused by bells and whistles and fancy features. Instead, we've seen the kind of pure version of the middleware pattern that's really simple and isn't distracting. At GoCardless, we've built a library called Coach, which is a more fully featured implementation of the pattern with a bunch of extra features. I'll take you through just a few of them before we finish. Firstly, with Coach, middleware can explicitly depend on other middleware. This makes it much easier to build your pipeline, as you can have a single point of entry. So our endpoint-specific middleware from before becomes a class like this, routes customers create. And then we use the users method to say that this middleware depends on other middleware. At GoCardless, we refer to the endpoint-specific code as a route, but really it's just a middleware like any other. Having this route class means that we can actually connect our code straight up to the Rails router. We can actually skip ActionController entirely if we want to. We still love Rails and especially love using active model, and we love Ruby in general, but we find the middleware pattern works better for us building APIs than using controllers. Having this mechanism of middleware depending on other middleware also means that middlewares can be configured, making them more adaptable and reusable. When we depend on a middleware using the users method, we can pass in configuration, and we can then refer to that configuration in the call method. So for example, here we make the access token middleware configurable. You can now say what permission level the user has to have. Middleware in Coach also define what data they pass on and what data they need. This makes your code easier to follow, and it's much easier to understand the flow of data. Here, for example, we say that the access token middleware is responsible for finding the user. So we say it provides a user. And then we say that the create route needs to have a user. It requires one. This gives us a really cool feature, which is a bit like static analysis. When our application boots, it can check all of our middleware and make sure the dependencies are satisfied. So for example, if I said here that I require a user, but didn't depend on a user that provides it, then my application would be able to error at boot, telling me that there was a problem. And finally, Coach has some really nice test helpers, which makes it easy to unit test your middleware in an elegant way that is declarative rather than long and repetitive. You can find Coach on GitHub as well. It's at github.com/gocardless/coach. With it, you'll find an example application and a blog post you can follow to get to grips with it. So now I just want to summarize. We want our code to be as maintainable as possible. That is, we want it to be understandable, testable, and reusable. But as I think we've seen, controller filters get out of control really quickly. You get to examples like mine where you've got 12 filters and a crazy array of things to scroll through. We've seen with a real example how we get towards unmaintainable code. The single responsibility principle points us in the right direction, towards simple classes that do one job. The middleware pattern is an example of the single responsibility principle in action, and it can help us to build better APIs. Simple middleware helps us to understand how things work, but with Coach, you can really hit the ground running with the middleware pattern and have a great developer experience too. Thanks so much for your time today, and I hope this talk has been interesting and useful. I'm happy to take any questions, and you can also find the slides with all the links on my website. Just go to timrogers.co.uk and then click speaking. I'd love to hear what you think, so do ask any questions, and I'll be hanging around to chat for the rest of today, or you can tweet me. I'm at Tim Rogers. Thank you.